Okay, this next topic is about data encryption or excuse me, data compression and encryption, excuse me. And they're somewhat related topics, but it's important to understand the different types of compression and compressed files and encryption in order to use them properly and understand some of the differences in the files you might use every day. So first of all, the compression. We want to compress files because there is a limited amount of storage space, even though hard drives and flash drives are huge today by comparison of what they were just a small number of years ago. With all of the high resolution cameras and videos that we can take on our phones, with all of the multimedia files, maybe you capture things on YouTube, wherever you find media, media just is space hungry. And no matter how big something feels, it only takes a short period of time and you realize that's not as big as I thought it was. For my phone, for example, I bought the biggest phone I could afford in terms of the storage space. I wasn't really that interested in a fancy phone, but I wanted the maximum storage that it could handle. And I had to buy a new phone recently. Now, yes, I did get a lot more years out of my last phone than most people, but it couldn't even hold basic applications. I had to delete everything that I didn't absolutely require for my day-to-day use. It was a 16 gigabyte phone. By today's standards, that's tiny. But and when I bought it, 16 gigs was on the higher end of the phone storage capacity. A lot of people laughed at me when I built my first computer. I actually made my first computer by buying all the components individually and put them together myself, and I learned a lot. It was not a cheap way to make a computer, but I got a much better computer in the long run than I would have otherwise. And in the process, I learned a lot. Huge amount of time investment, huge amount of cash investment, but I was in school at the time and it was a learning experience for me. And so I bought this 250 megabyte hard drive, 1/4 of 1 gigabyte. And people laughed at me. They thought, why are you spending so much money on a 250 megabyte hard drive? And now the smallest thumb drives you can usually buy are at least 8 times that size, a little tiny thumb drive. But back then that was a lot of space. And I blew through that space in about 12 months because I do photography and videos and things of that sort. And so how do you make things more efficient? You compress them. And with compressed files, you can often not only save space, but you can save other resources. So if I'm uploading a file onto my cloud drive or cloud storage space, I use less bandwidth. I use less of my allotted uploads if I upload compressed files rather than uncompressed files. And so it can be a lot less on my bandwidth for internet. It can be less on my local computer. And there are different compression methods. And the two categories that I want you to understand or know the concepts are lossless and lossy. Lossless means whatever you compress can be uncompressed exactly the way it was. There's absolutely no loss in the data integrity. There are limits. You can only compress those so much. If you're not willing to give up any of the data, then you can only compress so much. But that still is really, really handy. But let's say, for example, I want to compress an Excel spreadsheet file. When I uncompress it or I look at it, I want everything there. I don't want to lose some of my data. So if I compress an Excel spreadsheet, I need to get back exactly what I compressed. So lossless is very important. Lossy, on the other hand, it is a compromise. What can I give up without noticing? What can I give up with minimal impact? And so, for example, you're watching a DVD. A DVD is a compressed video. An HD DVD, high definition DVD, is much, much more information than the older original DVDs, but it's still compressed. And you might be familiar with all three of these on the lossy media. Your MP3 files, your music. You don't need every single 1 and 0, every single bit that went into a recording of a digital file. You can compress it and have a music file that is imperceptibly different from the original uncompressed file for most people's ears. And so an MP3 file, there's different levels of compression. The cheapy lowest level kind of, yeah, it doesn't take that much of an ear to tell that this is a compressed file. Those are 128 kilobytes or KB per second, kbps files. The 128 MP3s, you can fit a lot of them on your phone or other device, so they're popular for that reason. And if you've got crappy headphones or earbuds anyway, you're not going to notice the difference. But if you have a really nice stereo system, you can tell the difference. 128's not quite there. Then a little less compressed, the 256s or the 320s. The 256s are pretty damn good. Not too many people can tell the difference between the original file and a 256. The 320s even better because they're getting more information. 320 kilobytes per second of information being stored rather than all of it. And so, for example, an uncompressed DVD movie might be enough information to fill 20 DVD discs. 20. That would be crazy. Every 15 minutes, you're sticking in a new DVD, or more often than that, perhaps, depending on the type of movie. That's crazy. So we'd compress them, and they can look wonderful, and they look plenty good enough, even though we lost information. MPEG is a movie file. Maybe you haven't heard of that one. There's MP4s, and different types of movie files. And then images, the still images that you likely get on the internet, or the likely format of the images that your camera on your phone takes, probably JPEGs. JPG or JPEG, the JPEG files are a lossy, compressed image file. You'll lose a little bit of information, but in the process, you get more storage space, and you don't lose that much. A professional photographer is going to want a lossless. There are things like a TIFF file, TIFF. It is absolutely raw file that has every single dot on your picture. But that might take 10 times the amount of space to store that file compared to a JPEG or more. So lossless compression methods, the original data and the data after compression and decompression are exactly the same. That Excel file that I compressed, I uncompress it, I have the exact same file, lossless. Redundant data is removed in compression and added back during decompression. So redundant information, so for example, if I have a photograph, you can imagine that maybe there's a blue sky. And in that blue sky, there's a lot of dots that are the same color, maybe thousands of dots that are all the same color blue. Rather than having every piece of information for every single blue dot, I can compress that information in some sort of shorthand notation. And that's exactly the way the process works. And it is a mathematical process, and I won't go into the details, but lossless methods are there when you need all of your information back. I'm compressing Excel spreadsheets, Word documents, things that have words and data that I cannot lose. Computer programs, I can't lose my computer programming code when I compress it. So don't worry about the details. For those of you that are interested, you can look at the different types of lossless. And so this is an example of shorthand notation. When you have repetitive data, you make shorthand. So B's, I got 9 B's. I got 16 A's. I got 1 N, and I've got 10 M's. That takes up a lot less space than the original. So this is a simple concept of how you would compress the information, because what is the information? Just a string of bytes of information. And if you have repetitive bytes of information, you can compress them. So there are files like zip files, tar files, sit files, and many, many others. The one that most consumers tend to recognize are zip files. You have a zip file, or you can zip your files together. And there's another advantage to these types of files, such as a zip file, or another very popular one on the internet, a RAR file, R-A-R. You can take 10, 20, 30, 100 files and zip them together into one file. And if I'm sending somebody something, or I'm uploading something, or I'm putting something on the cloud for somebody else to download, I might take an entire folder of stuff and zip it together into one file. So I could have my Hartnell Farm proposal.zip. And inside that zip file, I could have 10 different subfolders and subfolders with 100 different files all zipped together. Now, with that much information, I'm not going to be emailing it to somebody. Most email programs have to be below 20 megabytes of maximum file size to email a file to somebody. And a lot of them even choke when you pass 10 megabytes, which is pretty damn small by today's standards. So email is not as good as a tool, and maybe all of you have run into this, or at least most of you, I'm sure, have run into this at some point, where you try to email somebody something and you can't, it won't send. So you have to find some other method. But even so, even if it does fit in an email, you've got a bunch of small files. Do I want to attach 10 small files to my email message individually? Maybe 10 isn't so bad, but it's a heck of a lot easier to attach one zip file and the person on the other end unzips it. And most people have a zip file decompression program. It's automatically built into Microsoft Windows. I'm not sure what's built into Macintosh, but they also have the ability to handle zip files. Very easy. There are also hard drive compressions where the entire hard drive can be compressed. On Microsoft Windows, you have the NTFS, the New Technology File System, which was new technology back in the late 90s, I think, when NTFS was first around. Don't quote me on that date, but it's been a long time. So it's not exactly that new of a technology, but it is a very efficient, very compatible file system. And you can tell the operating system compress the entire drive. Advantages, you're saving space. Disadvantages, if that hard drive ever has a problem or crashes in some way, there's a much bigger chance that you lose data on a compressed drive. If you're backing up regularly, you're doing what you should do, you've got a great backup program and routine, you're backing up to the cloud automatically every day, and everything important's being backed up, hard drive crash isn't that scary of a thing. But I warn people about file compression on an entire drive unless you really are good about backing up and you're doing what you're supposed to be doing. But you can certainly do it. A lot of people don't do it these days because big hard drives are so cheap and you can back things up on other drives, and because people are kind of sloppy about all their storage. If you had a drive fail on you now, whether it's a flash drive, your phone's internal storage, or any other device that you have, if it were to crash today, what would you lose? Do you have it backed up? I personally keep a backed up copy of my important files on my laptop, on my flash drive, and on 3 different portable hard drives, one of which I keep in the office, and one of which I keep at a family member's house that I only upload or change out about 3 times a year. But if anything were to happen and my house, heaven forbid, were to burn down, I've got my files at the Hartnell office when I can get there. Right now is kind of a crazy time. And all of, at least my old pictures and all of my major files are at a family member's house in another town. I'm not going to lose my stuff. And also I've got stuff on Canvas or other online places, Google Drive, things like that, where I've got stuff scattered around where I'm not likely to lose too much. But even with all of that, there are times I lose stuff. I had a hard drive crash 2 months ago, 3 months ago, and I was working for about 7 or 8 days on a really, really major project that wasn't my schoolwork project, but the drive I was working with wasn't going to crash. It was a really new, good drive, an external Toshiba USB drive that I had all of these files on. And I went to go back it up and I got a strange error message and the hard drive just died. So again, drives die. And I lost a week's worth of work on this really important personal project of mine, even though I'm really good about normally backing up. The gotcha on that one for me is I've got lousy internet, so I can't set up a cloud backup that would really have my back on other types of situations. Anyway, back to lossless compression. Certain images, audio, and video files may use lossless compression to save space while maintaining the original quality. I mentioned the TIFF files. PNG images, which are gaining popularity today by a lot. They're a great image file. We talked about PNGs because they support transparent colors. And WMA lossless audio. Not all WMA files are lossless. There's a WMA lossless and a WMA lossy. And I've got tons of my music collection that I've ripped from the original CD-ROMs, or CDAs, excuse me, not CD-ROMs, CD audios, my CD collection in not only MP3s, but WMA lossless. I ripped everything twice. DNG raw videos, they don't compress as much. So these are bigger files, much bigger files than the equivalents. The WMAs are a lot bigger than the MP3s. The PNGs tend to be bigger than most of the equivalent JPEGs. And TIFFs as well, TIFFs especially. So what about lossy compression? Used for compressing most images, audio, and video files because our eyes and ears can't distinguish subtle changes. So a little bit of loss is acceptable. It's cheaper to use, less time to do the compression. They maximize your compression so you use the least amount of space on your hard drives, things like JPEG, MPEG, and MP3. So let's take a short break.